Hello everyone, welcome to Code Staff Management. Today we are going to answer one of the most common interview questions asked in AI engineering and generative AI interviews. The question is like that, it is one of the scenario-based questions. So you can see this video under the AI engineering playlist as well as the scenario-based uh, questions playlist. Okay, so the question is like if LangChain can already implement loops and cycles, then why was LangGraph created? Okay, so at first glance, this seems like a simple question. Like many developers answer like because LangGraph supports loops. Okay, so but that's actually not the correct answer. Like LangChain already supports loops. So the real question is like why introduce another framework if the existing one can already do it. So by the end of this discussion, you will understand the architectural differences between LangChain and LangGraph, when to use each and how to answer this confidently in interviews. Okay. So just understand like what is LangChain basically. So before discussing the LangGraph, let's first understand the LangChain. So LangChain is nothing but an application development framework for building application powered by large language models. Okay, so it provides like reusable building blocks. What type of that? Like prompt templates, chat models, output parsers, tools, agents, retrievers, memory, chains. Okay, so think of LangChain as a toolkit. So basically, this LangChain gives us the components to connect the LLMs with the external systems like APIs, databases, search engines, documents, or custom business logic as well. So the main purpose of the LangChain is to simplify the LLM application development. Okay, so it basically helps us to connect the LLMs with the external systems, any APIs, any databases, any documents, search engines. Okay, so that's the funda of LangChain. So that will act as a framework, application development framework. Now we will understand like what is the chain. So the name LangChain comes from the idea of chaining the operations together. So like user will ask some question, then some prompt template is there, then LLM, then output parser and final response you will get. So every component executes sequentially. So this works perfectly for many applications like chatbots, any question answer systems, any document summarization, translation, classification, because these applications follow a straightforward sequence. Step by step we will go. That's the chain. Now, can LangChain implement loops? So many people believe LangGraph was created because LangChain could not implement loops. But that is false. LangChain can absolutely implement loops. So for an example, suppose we are asking an LLM to generate SQL queries. So if validation fails, we can simply execute see this while not valid, then generate query, validate query. Or like any retry document retrieval until enough relevant documents are found, or keep refining an answer until evaluation passes. So yes, loops are possible through this LangChain. So now manual loop example. So basically the workflow of the LangChain is like suppose imagine we are building an AI research assistant. So the workflow will be looks like search the web, then it will summarize you the results. After that, you need to evaluate the quality, and then if quality is poor, then the repeat research will be there. So using LangChain, this becomes ordinary Python code. So the orchestration is completely handled by the developer. Okay. So nothing is automated. So we have to call the LLM, evaluate the output, retry if quality is low, and repeat until stopping condition. So here need one custom state management. Now, what are the loopholes or what are the problems with these manual loops? So now the real problems begin. Just imagine your workflow becomes larger. Instead of three steps, you now have suppose six, seven, eight stages like first search, then read the PDF, then call API, summarize, evaluate, retry, ask human, continue, store memory, generate final answer. Okay, so this kind of like long chains will be continued. So after following, suppose see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. After these 10 steps, actually, we are generating the final answer. So managing this manually become very much difficult. So that is one problem. Okay. So the main challenging part is like there are several issues. First, state management. You need to manually pass the variables between every functions. Second, like retry logic. Like you must write custom retry code. Third, like conditional branching you need to do. Like nested if else statement quickly become unreadable. Fourth, like debugging, like finding like where execution failed. So that is become challenging part. And finally, like long running workflows are difficult to resume after interruption. Okay. So for that reason, like LangGraph came into picture. So this is exactly why LangGraph was introduced. When there is a long chains, long things are there. So then actually to manage by human, that is problematic. And that's why actually LangGraph introduced. So LangGraph is not another LLM framework. It is like an orchestration framework. So instead of writing workflow logic manually, you define your application as a graph. And each task became a node. So each transition will become an edge. So the framework controls execution automatically. Okay, so that's the graph architecture, like the graph based orchestration framework. LangGraph is nothing but the graph based orchestration framework, and it built on top of LangChain. So here you can see nodes represent the tasks, edges represent the transitions, and support cycles natively. So suppose search node, then summarize node, evaluate node. All nodes I have told, nodes are representing as tasks. So search node, summarize node, evaluate node, then decision node. So if the evaluation succeeds, go to end. Otherwise, go back to search again. Okay. So just understand like how the loops become part of the graph itself. So no Python while loops will be required. Now the state management. So one of the biggest advantage of LangGraph is like shared state, like central shared state. So instead of passing dozens of variables, every node accesses the same state object. So for an example, like user will ask a question, retrieved some documents, LLM response, and suppose so there is evaluation score, retry count, everything stays together. So this makes the workflow much easier to maintain. So state management is very much like user friendly here with the help of LangGraph. Now, conditional edges. So, LangGraph actually introduces the conditional edges. So, instead of writing like if, else, switch, nested conditions, the graph itself decides where execution should go. For example, if confidence will be greater than 90%, then finish. Else, need to do the retry search. So, the routing becomes declarative rather than procedural. Okay. So next is native cycles. So remember, like LangChain also supports loops, but in LangGraph, cycles are the first class citizens. Like they will get the highest priority like that. So the graph naturally supports returning to previous nodes. You know the graph concepts as well, right? So through the graphs, it can we can go back to the previous nodes. So this makes the retry logic, like reflection, self-correction, and iterative reasoning will be much cleaner. So that's the funda of native cycles. After that, checkpointing is there. So like imagine your AI agent has been running for 30 minutes. So suddenly the server crashes. So with plain LangChain, everything may restart. But when LangGraph comes, so with the LangGraph, execution checkpoints are saved. So the workflow resumes from where it stopped. So this is extremely important for like enterprise AI systems. So that is one of the important advantages or benefits of using the LangGraph rather than the LangChain. Now, human in the loop, like many enterprise workflows require human approval. Like for example, approve a loan, approve medical recommendation, approve financial transaction. So LangGraph allows the execution to pause. So it will wait for human input, and after that it will be continued. So this is difficult to implement cleanly using only LangChain. So with the help of LangGraph, we can do that easily. Now, multi-agent systems. So today's AI application rarely use single agent, right? So instead, they may have like planner agent, research agent, coding agent, testing agent, reviewer agent, DevOps agent. So LangGraph coordinates communication between all these agents. So each agent becomes a graph node. So now, a real production example. So suppose we are building a customer support system, like CSM system, customer support management system. So the workflow might be like receive a ticket, then retrieve the knowledge, generate the answer, evaluate the confidence, and if confidence is low, then escalate to human, store the conversation, update the CRM. So it representing this like as a graph. Graph is like much easier than writing nested loops and conditions. Now the comparison, like LangChain versus the LangGraph. So let's summarize the differences. Like LangChain provides the components, LangGraph provides the orchestrations. LangChain focuses on building blocks. LangGraph focuses on workflow execution. LangChain can implement loops manually. LangGraph supports cycles natively. LangChain manages simple sequential applications. LangGraph manages complex AI agents. So whenever there will be some interview and one interviewer suppose will ask you the question like if LangChain supports loops, why do we need LangGraph? So a strong answer would be like LangChain can certainly implement loops using normal programming constructs. However, LangGraph provides a structured orchestration framework where cycle, state management, conditional routing, retries, checkpointing, human approvals, multi-agents. So those workflows are built-in capabilities in case of LangGraph. So LangChain gives us AI building blocks, but LangGraph manages how those building blocks collaborate in production grade systems. So that's why though LangChain will support loops, but for enterprise AI application system, we always need the LangGraphs. So after that, common follow-up question can be asked, like the interviewer may continue with like, can LangGraph replace the LangChain? The answer should be no. Like LangGraph is built on top of LangChain only. So it still uses LangChain prompts, LLMs, retrievers, tools, and output parsers. So LangGraph only manages orchestration. Okay. So LangChain and LangGraph are not competitors. they solve different problems. So you need to use the LangChain when building AI capabilities, and you need to use the LangGraph when orchestrating complex workflows involving loops, branching, state retries, multiple agents. So the easiest way to remember this is like LangChain gives you the bricks and LangGraph gives you the blueprint or plans. Or if your background is Java, so you can compare it like LangChain is like Java classes and methods, and LangGraph is like a workflow engine that decides how those methods interact. We know about the Spring management, like bin management lifecycle, like right? So through our uh, Spring container or like that. So every beans you can consider as the LangChain, but through the Spring container, how the things are managed, IOC container and all. So those capability you can consider as the LangGraph. So I hope if you will explain it in this way in your interview, so you will demonstrate that you understand not only the APIs but also the architectural reasoning behind the two frameworks, the LangChain, LangGraph. We need to point that those two are not competitors. Simultaneously, we need to use those, and there are perfect use cases as well. Whenever there are some simple sequential workflow, we can use the LangChain, and when there is some complex AI system, then we need to follow the LangGraph. That's the concept. So I hope you got some good understandings from this discussion. So please do like, share, and subscribe. It will motivate me, and I will continue more such videos for society. Thanks everyone. Bye.